Up to you.
Yeah, it started.
Great. Hi, everyone, and welcome to this edition of our monthly meetup organized by CLIQ-ai, the Computational Linguistics in Quebec Consortium. My name is Fabrizio Gotti. I'll be your host. I'm a researcher specialized in NLP working at the University of Montreal and also for Ivado. Today, the theme of this meetup is the brain, more specifically mental and neurological health. It's a wide topic, admittedly, but the applications in NLP in these fields can be similar and are very promising and interesting. So we decided at Ivado to present this topic today. We have two interesting talks today and something special. We have a discussion panel later as well on our team. We're going to welcome Minlie Huang on emotional intelligence in dialogue system, and Stéphane Guay, who's a full professor at the Department of Psychiatry and Addictology at the Université de Montréal. And for the discussion panel that will follow, we're going to welcome these two researchers, as well as Jorge Armony from McGill University and Amal Zouaq, who's a professor at Polytechnique Montréal. So before we start, as usual, I'm going to ask everyone to mute yourselves so that we can enjoy the presentations without any distraction. And don't worry if you have questions. Every talk is going to be followed by a 5 to 10 QA session. So just write down your questions as they pop up, and at the end of the presentations, we can ask the presenters. So I think we're going to move on to our first presentation by Minlie Huang, who's going to present a talk on emotional intelligence in dialogue system. Dr. Minlie Huang is a tenured associate professor at Tsinghua University. He was awarded a Distinguished Young Scholar of the National Science Foundation of China award. His main research interests are natural language generation, dialogue systems, machine reading comprehension. He's an exceptional researcher who's won the Wenjun Artificial Intelligence Award from the Chinese Association for AI and the Hanwhan Youth Innovation Award from the Chinese Information Processing Society. He has hundreds of publications and citations as well. So we're extremely fortunate to welcome him today, all the way from China. So Professor Huang, it's really up to you. You can continue sharing your screen and present this when you're ready.
Okay. Thank you very much. Thank you for the invitation, and it's my honor to be here. So my talk will be emotional intelligence in dialogue system. So the history of dialogue system can be roughly classified into three stages. The first one is rule-based era. So from almost 1966 to almost 2011. And the second stage is about smart assistant era. So it's can range from 2011 to almost 2016. And the third stage is about deep learning era. So in this time, large-scale pre-trained models, for example, Mina from Google and Blender from Fair, and the GPT-3 or Plateau from Baidu, and Eva from Tsinghua my group. So it's a long time research, and also dialogue system is a very challenging research topic in long-standing artificial intelligence. So The first dialogue system can date back to 1966. The name is ELIZA, so created by MIT professor Weizenbaum. So you can see the dialogue system can simulate dialogue conversations as a Rogan therapist. So the conversation looks very natural, and you know at that time artificial intelligence is just at its beginnings. So this is a very famous system until today. And in 1972, the psychiatrist Kenneth Colby developed a system named Perry. So this system simulated a person with a paranoid schizophrenia, and the system even passed the Turing test. So there's only 48 chance to distinguish between the difference. So the judges present conversations from real patients, and also from the system generates the conversations. So so we can say this system can pass the Turing test in this circumstance. So since ELIZA is a psychologist and Perry is a patient, so they arranged a meeting, face-to-face meeting between Perry and ELIZA. So this is a very interesting test. So so this is a very old dialogue system, almost 30 to almost 50 to 60 years ago, and in 2020, Google developed a system named Minlie. So this is a very large-scale neural generation models for dialogue generation. So you can see we have almost 2.6 billion parameters, and trained with almost 40 billion words, and take a lot of time to train on a TPU hardware. And you can see the system can deliver very natural and very good conversations. So in this case, the dialogue system talk about a joke, tell a joke. So we can see the cow is very college. They go to is very smart, and then they go to college. And they went to Harvard. So the human said, what did the cow study? So say it's a Boeing science, and the human also further ask the horse go to Harvard, and Minlie tells us a joke about go to Harvard. So this is a very good joke, and it doesn't appear in the training data. So almost 1 month later, Facebook delivered a dialogue system named Blender. So it has a 3 version, and with different parameter scale, and using a lot of data to train. And also the system blending different skills, for example, personality and knowledge and empathy. And it can deliver very natural and high quality conversations talking about talking about the topics of Steve Jobs. So you can see this conversation is a very good one. And for Chinese dialogue system, I think it's almost 1 year or 2 years later than the English counterparts. So Baidu, they developed the Plato with 2 versions. One is 1.6 billion parameters, and another one is 10 billion parameters. And they are not, however, they are not open source. So from my group, we also developed EVA version 2 with 2.6 billion parameters. And very recently, just maybe just 2 days ago, we in this week we will release a new version OPT named Open Pre-trained Dialogue Model. So this has almost 6.6 billion parameters from my group, and we compared our system with the existing Chinese dialogue models. We can see we have very good automatic evaluation scores For example, the brute score is much better than Plato. And also we have very good knowledgeable response ratio. That means our system can deliver more informative responses with good knowledge. So today we will talk about emotional intelligence. So emotional intelligence is defined by two psychologists in America. So it is defined was the ability to monitor one's own and other people's emotion, to discriminate between different emotions and label them appropriately, and use the emotional information to guide thinking and behavior. So it can date back to the very early AI research by Marvin Minsky. He said the question is not whether intelligent machine can have any emotions, but whether machines can be intelligent without any emotion. And Rosalind Picard is a professor from MIT. He is a pioneering research in affective computing. So she said, if we want a computer to be genuinely intelligent and to interact naturally with us, we must give computers the ability to recognize, understand, and even to have and express emotions. So if we want to build an emotional intelligent system, we have 3 levels of research. So the first one is emotional chatting. That means how can we generate emotional responses? So this is a single interaction, and the challenge is to try to select a proper emotion and generate consistent emotion responses, not only to the given emotion but also to the context. The second one is empathetic chatting. So how can we generate empathetic responses? So this could be single interaction, but also multi-turn interaction. So the task is to try to understand the user, the situation, and the feelings, and express empathy and understanding. So the last one is about emotional support. So we try to generate supportive responses and reduce users' emotion distress and guide them through the challenges. So we must use the multi-turn interaction with the user. So it's a long-range interaction. And the key challenges is try to understand users' situation and the feelings and comfort them and provide solutions or suggestions. So this is very difficult. So the first work I want to talk about is the emotional chatting machine. So we collect a lot of dialogue corpus from social media data. So we have post-response pairs or multi-turn dialogue data, and then we build an emotional classifier to label this data automatically with in terms of happy, angry, and sad and so on labels, and then we send this kind of data into a deep learning model. So when you're giving a context like this, and also if we specify a emotion label, for example, happy, sad, anger, and then we can generate the corresponding responses. So this work is highly cited in the literature, and we published in CLIQ-ai 2018. So the second level work is about empathy. However, empathy is a complex, multi-dimensional construct with no globally accepted definition. In psychology study, there's many theories about empathy. Generally speaking, we have 3 different definitions. The first one is meaning-empathy. That means try to imitate or mimicking another's emotion without experience them oneself. So this is a base for sympathy. So the second one is sympathy. This is intentionally reacting emotionally. So this could be understood as feeling for. The last one is empathy. So this is understanding another one's feelings. So this is a feeling as. So for empathy, we have basically 3 elements. The first one is emotional reaction. So we try to express and showing emotions. For example, in this conversation, I'm nervous about my exam. So if we try to express implicit emotion, we can say everything will be fine. And if you want to try to express deliver explicit emotions. We can say, I would be nervous too when I was not ready for my exam. So you can see this is better than the second one, and the second one is better than the first one. And the second element for empathy is interpretation. This is to try to show you an understanding of the user's situation. For example, if the user say, I have no friends. So if you say, that's very interesting, this is not a good response. There's no understanding of the user's feeling. And the second one is I understand how you feel. So this is provides generic understanding about the user's situation. If we say that sounds really lonely because no friends is highly correlated to lonely, so we can provide specific understanding so the user will be feel better about this. The third element is about exploration. So we try to improve understanding of the situation by exploring users' feeling. So for example, in this case, I think my classmates dislike me. So if we can do generic exploration, that means what happened, right? And the second one, the better one is we do specific exploration. So we can say, I wonder if this makes you feel lonely. So this is a better response. So in this topic, when we try to build an empathetic dialogue system, we have different research topics in the literature. For example, in this one, they also say we should generate responses based on how our users would feel towards them. So this is with a look ahead strategy. And in this paper, they say we should understand the user's emotion and respond appropriately. And in this paper, it's about how about generating responses by mimicking the user's emotion to a degree. And also we have work like we need external knowledge to understand the emotions, right? And also in this work, there are also think emojis are important too in emotion in building empathetic dialogue system. So in this year, we published a paper in CLIQ-ai, and we say its emotion is all we need. So we will talk about this work. So empathy consists of affective and cognitive aspect. In affective empathy, we try to detect and simulate the user's emotion. In cognitive empathy, we try to understand the user's situation and feelings. For example, their reaction, their intents, their needs, and so on. In many situations, the users might not be explicitly talk about their situation and feelings. For example, if a user says that the principal asked for my parents to come to school, so we can draw many implications from this sentence. For example, the user may feel sad or anxious. She or he may feel have failed an exam. They may want to talk to their parents. So this is the case. And as humans, we use our knowledge and the common sense reasoning to draw these implications. For example, if a user said, I have a chance to make some money, but my phone screwed up. So when the user said this one, and his emotion reaction may feel regretful or frustrated, right? And he wants to do what he wants to do. Maybe he wants to buy a new phone. So if we combine these two information together, so we can say, that's terrible. Have you gotten your new phone yet? So in this sentence, it's similar. So we try to use a generative model to infer how the user reacts to the situation, or what the user would want after the event, or what was needed for the event to happen. So we build a deep learning model like this, giving a context C here. So we use a context encoder to represent the information into a vector. And then we use a knowledge acquisition module to infer this kind of information. So we append a relation token. So this is X react, X intent, X need, X affect, X want. And then we use a generative model commit to generate some sentences for each relation. So we have 5 relations. And then we encode these sentences. And then we do some vector manipulation. And then we combine this context information and this knowledge information together to deliver more meaningful and responsive responses. Okay, so this method is a very simple one, and we do automatic and manual evaluation. We found that this simple method has very good result, and it can beat the state-of-the-art baselines. And we have received a number of citations since published at the early of this year. So the third level empathy I want to talk about is emotional support. So emotional support is a non-term interactions. So it needed many professional strategy, and it should be grounded on psychology theories. So let me show an example. So if a user say, I feel so frustrated, so we can first ask a question, may I ask why you are feeling frustrated? And the user says, my school was closed without any prior warning due to the pandemic. And then the robot can say, that's really upsetting and stressful. This is affirmation and reassurance. And then I would also have been really frustrated if that happens to me. So this is a self-disclosure. So this strategy, the red one is about the strategy. Is borrowed from the psychological counseling theories. So I will talk this later. So we build a computational model grounded on the hearer's helping skill system. In this theory, the authors design 3 stages and the corresponding strategies to do effective emotional support. So the first we need to explore to identify the user's problem. The second stage is comforting. So we need to comfort the seeker through expressing empathy and understanding. The last one is action. So we try to help the seeker take action to cope with the problem. So at each stage, we design concrete strategies. For example, at the exploration stage, we have a question, restatement, paraphrasing, reflection of feeling, and self-disclosure. For the last stage, action, we have 4 strategies. So the last one is information. The second and last one is providing suggestions. So for each stage, we have corresponding different strategies. And this is the strategy and the corresponding examples. And also for each strategy, the lexicon features of the typical questions. For example, for the self-disclosure, we would say, I feel the same way. I also don't know what to say to strangers. So we have do some analysis on how these words are used. However, when you do this kind of research, you don't have any data for this. So we ask for Mechanic Turk, Amazon Mechanic Turk, and we design seeker and support mode to collect the dialog data. So we design different mechanisms to ensure high quality emotional support conversations. For example, how to train supporters, and we need to ask them to pass the qualification exams, and then we do a post-chat survey, and then we have some auto approval program to detect the high quality conversations. So this is a screenshot about the interface. And then we do a manual evaluation compared with the different models. We can see the result has significantly much better than the baselines. The one baseline is the original blended board, and also we try to based on the blended board, we fine-tune the model using our ES conversation data. So this is pretty good. So next, I will talk about the importance of mental health. As we know, there are about 350 million people diagnosed with depression worldwide, and also every year there are more than 800,000 people committing suicide. So this is a lot of people dying from the depression. And then for China, I think there's more than 100 million patients diagnosed with depression. However, most of these patients didn't receive any good or proper treatment for their mental illness. So we tried to build the first Chinese empathetic chatbot that mimics professional counselors. So we built a deep learning model with 3 billion parameters, and the training data amounts to almost 50 billion tokens. And we have collected the log, and we analyzed that the average conversational term per session is about 27.8. And also we try to compare our system with CR-IUSSS. It's a very famous dialogue system in Chinese. And we did a double-blind test, and we recruited about 100 judges, and there comes out about 2,000 utterance, and with almost 1,000 dialect terms. Okay, so let me show the video.
Emoha, the world's first chatbot.
Sorry, it's in Chinese.
It was trained with fundamental schema and knowledge of human emotions and feelings and thousands of mental health counselors' dialogue, clinical technology, and evaluation. Emoha also has better listening skills, understanding of emotions, and more empathic responding strategies than generic chatbot. So Emoha is capable of relaxing users' negative emotions and providing essential support. For example, when faced with a middle-aged male who has insomnia and work stress, Emoha would evaluate the severity of his insomnia and learn more about his sleep hygiene to provide a guided conversation. Like mental health counselors, during the exploration, Emoha would facilitate users to talk more about detailed information of his stress, mental distress, and negative thoughts under the model of clinical practice, even without any professional intervention from mental health professionals. Emoha supports users' mental needs, releases their anxiety, and provides strategies of stress handling 24/24. As Emoha was trained under one of the evidence-based practices in mental health, cognitive behavior therapy (CBT), it is able to facilitate cognitive behavior techniques and practices to improve the mental health of users and decrease mental distortions in daily life. Emoha is recognized as a junior mental health counselor. With an era of VUCA coming, Emoha is tailored for everyone who has mental distress and emotional issues. Emoha helps them face daily life and emotional problems with a more rational, optimistic, and positive lifestyle.
Okay.
Emoha, the world's
Let's move on. So going further, so we also try to answer this question: can Emoha be used in psychiatry treatment? So we recruit some subject for experiment. So there are almost 400 applicants, and after 3-stage filtering, there's 134 participants go into the experiment finally. And we do 2-week intervention. So we have 3 groups. The first one is using the CBT training. And the second one is, in addition to the CBT training, we also have emotional support chatbot. That means using the Emoha chatbot. And for the control group, there's no intervention. And then we use the 4 mental disorder scales to evaluate the effectiveness of the intervention. For example, PHQ-9 and GAD-7 and PNAS and so on. And here the result. We can say there are significant difference between the insomnia of the 2 intervention groups after the completion of the study. Specifically, participants who only used the Emoha with CBT-based training experienced a slight increase in insomnia 3 weeks after the intervention. However, those who had access to emotion full showed continuous improvements even after the initial 2-week interventions. So this is a positive sign of the effectiveness of the chatbot. And also we collect a lot of user feedbacks. So whether this chatbot is a proper chatting partner, whether is suitable for emotional venting, and good for counseling and to explore user emotion, and also the user, whether the user can feel heard, and also the overall recommendation. So we have almost more than 60% recommendations. And then we going further. We try to use the deep learning model to generate a psychology question answering. So we collect high quality Chinese status of mental health support in form of question and answering pairs. So from Chinese Minlie, and we do strategy annotation based on the psychological counseling theories. And then we can deliver when a user has a question like this. So this is describe a situation and about his emotion issues. So we learn from the human data with the professional strategy. For example, the blue one is about providing information, and the green one is about restatement, and the red one is about interpretation, and the yellow one is about direct guidance. So we can use this kind of strategy to generate a more structured and more responsible replies. Okay, this is a video for this system. Hello, so we can type a question here.
Now I would like to introduce our open domain QA system for auxiliary mental health supporting. The goal of our system is to help mental health supporters automatically analyze and answer questions about mental health from help seekers. Next, I will demonstrate our system. First, input the question and description of the seeker in the left boxes, and then click the Submit button. We can see the answer has begun to be automatically generated, and the results of mental problem analysis and crisis detection are displayed under the output box. The sentences corresponding to different helping strategies are marked in different colors, and will highlight when the mouse hovers over it. After generation, mental health supporters are allowed to click Copy button to make use of and further edit the content. At last, Clear button is used to refresh the page, and then helpers can input the next question and description.
Okay, so however, we also compared the model-generated responses and compare model-generated responses with the human provided ones. So we can see from different aspects, for example, fluency, coherence, relevance, and helpfulness. The score from the model is still far behind the human result. So we have almost one point gap. So the maximum score is 3 points. Okay. So to summarize my talk, I talk about emotional related dialogue tasks, but they are very complicated, and there's some key factors to the success of this kind of dialogue system. For example, emotional affect understanding is very important, and the domain expertise and knowledge is very important. Here is a psychologist theories, and also I think the strategy for accomplishing long-term goals is very important. For example, in here we using the here's helping skill system, right? And the e-mental health is a significant application for dialogue system, but it's very challenging and also exciting, valuable, and worth to do. So this is my talk. And this is some related paper published in my talk. So thank you very much.
Thank you so much, Professor. It's a very interesting talk. I think you can. We certainly have time for questions. So if you have a question, you can either use the raise hand tool, or we'll give you an opportunity to talk. I see that, Professor, maybe it would be best for you to minimize the window with the chat,
Okay.
because we see ourselves. That's
Okay.
only the. So I see that we have a question from Tufik Mishuma. Tufik, the floor is yours.
Okay, thank you. So, well, thank you for the very interesting presentation. Well, my question is, humans have the ability to grasp the meaning of words and the concepts they refer to. And based on that understanding and consciousness, humans generate emotions. So emotions are reactions and not actions. Yeah. And we presuppose that we understand before we generate emotions. So in addition of that, even people may misconsider other people's social background while discussing. So how do you deal with understanding meaning of the words before talking about emotion detection? And how do you deal with the social background of human? Because we do not have the same social background. So we may talk with people from Africa or from North America, and words may not make them happy all the time.
Yeah, this is a very good question. So we have undergoing work to deal with the social background and try to understand the use of the emotion more effectively. However, in today's talk, we only using the data-driven task, data-driven method. So that means we did not explicitly to deal with the social background and try to understand the use of the emotion. Instead, we just try to learn from a lot of data. But we do some professional annotation of the data using the psychology expertise. So you can see here, during our work, we try to annotate the data, so tag them to different strategies. So, and you can see here in Chinese, question answer generation. So we also do some annotations for each sentence. And then we try to say, okay, this sentence is about providing information, and this sentence is about a restatement. So this is the level of the annotation we for the moment we do. But in the future, I think there's a lot of work to do. Just like you said, how can we take the use of the social background as an input, and also how can we recognize the use of the emotion with a fine granularity. For example, we can do emotion recognition with more than 30 classes. So this is a very fine grained recognition. But in this large generative model, we didn't model this kind of information explicitly. Yeah, instead of implicit. Okay.
Okay, I do agree with you. There are a lot of things to do in this field. So thank you for answering my question.
Yes, emotion is very complicated. Yeah.
Maybe I have a question myself, Professor. On slide 30, there's something I don't understand on slide 30.
30?
Yeah, 30.
Here, right?
Yeah, you say that participants who only used EMOHA CBT-based experience a slight increase in insomnia, so it's a negative result.
Yes. So we have two groups here, right? The first one is they only use the CBT training to do the intervention, right? So after the intervention, insomnia increase. So this is not good. However, when they additionally have the access to the chatbot, they have continuous improvements even after the initial 2-week intervention. That means that they didn't go back to the bad situation.
Oh, I understand. Thank you. It's much clearer.
Okay. Okay.
We have a question from Professor Amal Zouaq. Amal?
Yeah, thank you. Thank you very much for the presentation. I just had two questions about, I was curious if you performed any analysis of the types of failures that these models experience. As we see, there's a lot of knowledge that is involved, so common sense knowledge, domain knowledge, psychology knowledge, and maybe many others. So do we know if there is a particular type of knowledge that these systems seem to be lacking or have hard time with?
Okay. Okay. You mean the failure cases, right?
Yes, exactly.
Okay. Okay. Yes. Yes, we do have some failure cases, and but I didn't provide it in this presentation. So in fact, you can see here for the GPT model generate answers, the score is still far below the human answers, right? So almost a 1 point gap. So this is a large difference. And also we do manual evaluation about the result. So there's some, I think there's some very not good cases. For example, some machine generated response will trigger crisis to the human. So this is a very very critical, right? And also for some answer, it's not professional. So that means it's not proper for the user's case. So we have bad cases, and we present in this paper. So maybe afterward we can check. Maybe you check out. Yeah. Let me see. Yeah, this one. So we do some bad analysis. And also for this paper, I think we also present some discussion about the ethic issues of this kind of work. And during the paper submission, the reviewers are also very caring about the ethical issues. Emotional support research is in fact very, very complicated and should be very careful.
Okay, thank you very much.
Thank you so much, Professor Huang. Very, very interesting. I think that we'll move on now to our second presentation.
Okay, thank you.
Thank you again. So our second presentation will be made by Stéphane Guay. His presentation will be on narratives as text mining to improve the prediction of PTSD, post-traumatic stress disorder. Stéphane Guay is a full professor at the School of Criminology and the Department of Psychiatry and Addictology at the Université de Montréal, and he holds a doctorate in clinical psychology. He specializes in the study of management of victims of serious violence in the workplace and individuals who have developed PTSD. He's the director of the research center of the Université, Institute of Mental Health in Montreal, where he directs the Trauma Studies Center. So I think that we're going to invite Professor Guay to share his screen.
Do you see it?
Yes.
You do? All right. I don't, so...
You can minimize the Teams window and then launch the presentation. Yeah, just, yeah.
All right, that's it. Okay. Is it in the...
No, we see, yeah, that's perfect.
That's perfect. All right. Thank you. Well, thank you very much for the invitation. I would like first to say that, well, I am not an expert in NLP. I am a clinical researcher who specializes in post-traumatic stress disorder. So, and I am here to exchange with you. I know that many of you are experts in NLP, and I would like to maybe look for a collaboration with some of you and around this very interesting project. I'm here with my Axel Center co-director hat. So Axel is a strategic platform of the research center that I am the scientific director of. And so we have launched the Axel Center to accelerate the development of the digital innovation for mental health 4 years ago. And so we have developed an academic partnership with Ivado that we are very proud of. So today I'm going to talk to you, of course, about mental health and more specifically about post-traumatic stress disorder. But so far, my experience with people in AI was characterized by a lack of knowledge about the importance of mental health in the society and of mental health disorders in this society. We know that a lot of people, especially in Canada, but not especially, but in Canada, over 6 million people will suffer from any mood disorder during their lifetime. And that this generates, and these data are from 2012, so we can believe that the cost of mental health disorders has, of course, increased substantially, more specifically during the pandemic. But a lot of expenses are impacted and about with mental health issues, and including workplace productivity losses. So our objectives at the Axel Center is to support researchers in their use of innovative technology and artificial intelligence to enhance efficacy of traditional predictive and treatment approaches with digital phenotyping. And secondly, to develop new solutions to facilitate and increase access to mental health care. The presentation of the preceding presenter was really interesting in that sense, and this is exactly what we are aiming to for the future. With digital phenotyping, we aim to characterize and predict the behavior and mental health states from data generated by human interaction with digital devices, either physical hardware or software. Why? Well, that's because so far most of our predictive models were based on diagnosis symptoms that are related to DSM-5 or DSM. The DSM is a diagnostic statistical manual of mental health disorders. And we have been limited in our ability to predict who will develop any kind of disorder, as well as who will benefit from treatment. And of course, then we are also limited in how we can improve the effectiveness and the efficacy of those treatments. And so we have to turn, I think that turning to digital phenotyping, and I'm not the only one, of course, thinking about that, is a very promising way of improving our ability to treat people more thoroughly and and by being more effective. So we aim to understand, of course, to understand or predict the emergence or evolution of psychological difficulties. we have seen, for example, during the pandemic, we have studied this, me and my colleagues, health professionals, and we have assessed them with ecological momentary assessments over time, over a period of 12 weeks. And we have seen many different evolution of psychological distress among these people. So it's not just one pattern, there can be several patterns. And this is why, of course, we need to improve our predictive ability to identify those who are more at risk of having a durable distress, and to, of course, prioritize them in prevention and treatment efforts. Of course, digital tools are a great asset to do this digital phenotyping, and but there is always a challenge with the user experience of a digital technology. So it has to be very well refined and individualized and personalized as well, so that people will use them to get in contact and develop some sort of a relationship with the digital tools. So to do so, we need to, of course, not only computerize adequately our tool, but we have also to design them very well. So this is a new area of research that has emerged in recent years. There is a correlation between the quality of the digital design and the efficacy of our digital tools. Finally, of course, we need to diversify what we will be assessing with these tools to have a wide array of different potential predictors, such as cognitive, autonomic, neural mechanisms of action, and of course, what we do as actions within psychological treatment or prevention treatment, so that we include these features in our prediction models. So now I will get into the more specific goal of a project that I have been thinking about for a few months now, that I've started to develop with some of my colleagues. And it is regarding PTSD and the prediction of PTSD. So some of you might know, but we almost more than 3/4 of the Canadian population will be exposed to a potentially traumatic event during their lifetime. So what is a potentially traumatic event? It can be being physically assaulted, having sustained sexual abuse during infancy, being in a car crash. It can also be in an accident, like cutting our finger with a saw, so etc., etc. And but we see that even if these very potentially traumatic events do not lead to post-traumatic stress disorder every time, not at all, actually. The majority of the people will overcome the impact of these events and will not develop PTSD, which means that they will adapt adequately to these and will never develop PTSD in their life. However, there is this 10% of people who will develop PTSD and who will probably, because of that, sustain dramatic change in their capacity, in their functioning capacity as a parent, as a worker, and as an individual who will be able to contribute to the society. So identifying who will develop PTSD after a potentially traumatic event is a major challenge that is of great interest, especially for militaries. I have not mentioned those potentially traumatic events, but of course, military trauma are a kind of event that we know we are well aware of, and so. If we could better predict who will develop PTSD after a potentially traumatic event, we will be able to, well, increase the efficacy and, of course, the effectiveness of what we do, and we probably prevent also a lot of PTSD. So, and this is where text mining of narratives of traumatic events can help. And so of course, with the help of natural language processing analysis. What is PTSD exactly? Well, according to the DSM-5, there are 4 clusters of symptoms that you have to experience to be diagnosed with a PTSD. First, you have to re-experience the trauma according to different ways with cognitive intrusions, nightmares, etc. Second category of symptoms is persistent avoidance associated with the trauma. So it can be, to avoid talking about it, thinking about it, going back to where it happened. So if it happened in the workplace, people will have a very hard time of reintegrating their occupation. Third cluster of symptoms is disturbance in thoughts and emotions. Usually a lots of guilt or shame, anger, fear, of course, but also a sense of a shortened future that is, and may sometimes also of numbing with towards our close relatives ones, and so this is where, of course, it impacts a lot our capacity to interact with the others. And finally, the fourth cluster of symptoms is hyperactivation of the nervous system. And this relates to hypervigilance, difficulty in concentration, irritability as well, and these are also very disturbing. So to develop PTSD, you have to evolve toward all these clusters of symptoms, because you have to have at least 1 or 2 or even 3 symptoms in each of these clusters to be diagnosed with PTSD. And this is why there is a lot of variation. I told you that not everybody would develop PTSD. And you see here that there are different trajectories of evolution of symptoms. And this is also interesting because it does give us a lot of variability in the outcome that we aim to predict. But we have to follow them in time. As you can see in this graphic, some people will stay quite stable over time, while others will improve, and while others will also increase their symptoms. So we really need to be able to identify those who, for instance, will be in the chronic trajectory or in the delayed trajectory. However, we could also target and help those who are in the recovery trajectory, and to maybe accelerate their rehabilitation. So a lot of potential if we can, again, identify those who will develop or will be at risk of developing PTSD. Why text mining? There could be other ways, and we have tried other ways. I would tell you that over time, and since I've been studying PTSD for the past 20 years, there have been a few meta-analyses that have looked at what are the major predictors of PTSD, and unfortunately, there are very few who are very stable across studies. The most powerful are with regard to variables that cannot be changed, like sex, age, as well as the number of prior traumatic events. So these are all things that cannot be changed, and so and the only variable that is not pre-traumatic, that is post-traumatic, is the quality of social support after the event. But now and for many years, one researcher named Pennebaker has looked at the textual information that is related to adaptation to stressful events, and he has developed a very strong predictive models for those who experience stressful events and not traumatic events. And more recently, in the past 10 years, some of his colleagues have developed a new way of targeting textual information for those who have experienced a traumatic event, and have succeeded in producing a new form of treatment, which is called writing expression treatment. And so they have managed to give instructions to patients who have PTSD to modify the text that described their traumatic event. And but these instructions are not especially finely described, or they do not come from specific predictive analysis, and because at the time Pennebaker did not benefit from these types of analysis, and so but still the instruction given to modify the text is effective. So but now what we would like to do is to identify the textual information that not only is associated with PTSD, so that can be used as a screening instrument, but we would like to use this textual information to predict over time, like 2 months, 6 months, even 12 months later, who will develop the PTSD, because, and why? Because of course we see that these people, these trajectories here, they tend to develop later in time. So we might not at the beginning or shortly after the event be able, just by their symptoms, to identify those who will have PTSD. We need also to work with those who will evolve more negatively over time. And so with text mining, we can extract language features as well as features reflecting affective, social, cognitive, and perceptual processes that will be indicative of a risk or not of developing PTSD. And we could also integrate them in a more thorough predictive model that includes, of course, more other information, such as the predictive factors that I told you earlier, that were sex, age, and number of traumatic events experienced in the past. And this information is quite easy to acquire. We can ask people to, write, let's say, 150 words text, and we could ask them this repeatedly over time. And so eventually we could even see with this kind of repetitive or assessment design, we could see what changes among those who do develop PTSD and those who don't. And so we could refine our model, our predictive model, and we could also, of course, refine the treatment that I told you earlier, which the acronym is WET. And so we could improve WET by identifying the components that are associated with improvement and with also treatment efficacy. Why not? So our project so far that we have discussed, well, we want to with natural language understanding and text mining, we could extract the information from the narrative about the traumatic event. So what happened, when, where. We can detect any words or expressions that are indicative of emotion, thoughts, or feelings related to the traumatic event or to the development, of course, of it. Identify text components predictive of later development of PTSD, and integrate those eventual predictive algorithms in a therapeutic digital tool that could, of course, that will need more. That is not easy to do, but that could be very helpful. And why? Because in the WET treatment, and according to the Pennebaker's approach, there is an assumption that people have to write by hand these texts. And of course, in 2022, we don't use a pen and pencil so much anymore, except me, because yes, I do use my pen. I am 53, and I've been trained to use that. But if we look at more younger, of course, adolescents or young adults, even though, and those the strat of age from 18 to 25 in the population is the most highly exposed to potentially traumatic event. Of course, they would want to work with their smartphone and not with a paper and a pencil. So we have there is this challenge that we have to first also demonstrate that writing with our thumbs is as efficient as writing with a pen. So this is one step that we have to take before. And finally, well, you can hear that I have this French accent, of course. I live in a French, we live in a French speaking province here in Canada. And at the beginning, when we looked at the different way of analyzing text, and from what that was published earlier, well, we found that there was not much in regarding French dialects, and this is a challenge. Although the presenter before me seemed to be able to maybe overcome this problem with maybe. And I would like to hear a lot, of course, about that. So, so these are some of the foreseen challenges that we look, and well, that would be the end of my presentation, and I would like to, of course, exchange with you and take your questions.
Thank you so much, Professor Guay. Very interesting and ambitious presentation. Of course, we have time for questions. So if you have suggestions or ideas regarding the presentation that Professor Guay made, well, now is the time to intervene. You can use the raise hand tool in the upper right corner of Teams to propose suggestions or to ask questions. So
I'll take notes.
So just a quick note, Professor Guay, maybe a way to reconcile the younger generation with the use of pencil and paper would be to simply write down the narrative on a piece of paper and then photograph it with their phone and send it your way.
Good. Thank you. Good suggestion. We could do that. So some sort of algorithm could read the text, the written text.
Yeah, algorithm are pretty good at that nowadays.
Thank you.
I see we have a question from Professor Jian-Yun.
Yeah, thank you, Stéphane. That's very interesting to try to detect whether those people may have some problem or whether we can help those people. One question is about what kind of features we can extract or we can observe from the text so that we can recognize or detect some problems from those texts. So what are the kind of features you are trying to apply in this problem?
Well, two answers, two parts to my answer. One of them is that when we do the clinical work with these people, we do go over their memories of the event, and we worked with verbal memories, and so and then we asked questions about these memories when some features are missing. So people with PTSD will tend to avoid certain facets of the event, usually the most traumatic ones, and so they will, let's say, I don't know how you say it in English, ils vont tourner autour du pot. That means going in circle around the traumatic memory. So they will talk about, well, it was nice outside, it was 10 o'clock, and usually they will talk a lot of things that were happening before. I was finishing dinner, and so they don't talk about, well, when the man entered their house, and tried to rape them, for instance. So this feature is a thing that they will avoid at the beginning, and that we will try to introduce in the narrative of their memories gradually. Of course, we would not, and so this is one thing that is very nice about writing, is that people can go at their own pace. So they are not forced to do that, but if they are instructed to do so gradually, of course, well, then they will maybe by themselves come to that. So this is one part of the answer. The other one is that with the wet treatment that I talked to you earlier, there are some instructions that were developed by Pennebaker like 30 and 40 years ago, asking people to write the narrative of their event at the present tense, for instance, not in the past tense. So this is an assumption that writing at the present tense is more therapeutic than at the past tense. So this is one thing I would like to investigate. Is it necessary, or is it necessary for everybody? Or not, and then we could maybe continue or pursue to give this instruction or not, depending on different factors. So there is a lot to investigate even in a small text of 150 words. There are things that we could, we can make a lot of hypotheses about what we could be looking for.
Okay, thank you. So the following follow-up question is about why is it important to handwrite a text instead of typing a text on smartphone? Can you extract the similar features that are useful?
that's an empirical question that we need to address. Is it generational? Is it for people, you know, is it more therapeutic for people like me, or and not for younger people? Or but that we need to, so is there something related to moving our hands and related to any, you know, brain processes? Is there, we don't know. That this would be an interesting also, so I think we have to divide this, even if maybe my projects seem simple, or you know, well, there's a lot to investigate about that, and there's a lot to learn about that, and if we do find answers to some of these questions, we will be able to develop a tool that can be accessible to a lot of people, and that can be even auto-administered, you know. So we don't necessarily need a therapist, which is very important, because there is a decrease in the number of therapists available, of course.
Thank you.
Thank you for your question, Jian-Yun.
Are there, yeah, we have another question from Laurent Jacobin. Donc, Laurent, c'est à toi.
Yeah, thank you for the nice presentation, Professor Guay. I have a question. You presented your project, but what is the state of the project currently on the technical aspect? You mentioned you would like to search into text and do text mining. Do you have any databases of those texts already available? Did you work on that already? And did you make work on those texts already to be given to any kind of researcher, like the anonymization of the text and something like that? Or are you still in a state where all of that need to be planned and build a roadmap of everything that needs to be done?
Well, we do have text, but they are not ready to be analyzed. They are so far they are audio recorded, and so we could translate them, of course, in writing. But in the project, so it could serve as a pilot study, you know, to train maybe the algorithm. But I think we really need to do a prospective study with that, and use. We could recruit people who are oftenly exposed to potentially traumatic events, and follow them in time to see how and so we could see how they adapt in time, as well as those who will fall into more solid trajectories, you know, towards PTSD or not, or towards resilience. But so I think that the repetition of writing will be important, and this is why I think we would need, but to do a prospective study with, and I would like to know, of course, if we maybe you or anybody else, how many do we need in terms of data? So this is a crucial question, I think. So do we need 1,000 people that we will write 5 texts, or is that enough? So these are questions that I would like to address with any of you as specialists.
Yeah, the reason why I asked the question in the first place is that I'm working with Imajac Anaxia Elf, and it's in the clinical domain. And we have tried in the last few years to participate in projects with other hospitals. And one of the major problems we get every time is the access of the data from the clinical perspective. So be sure that the study having prepared on the clinical side, having a RIB numbers to get access of those data, to be sure that the data doesn't mention any name of any patient. So there's a strong effort to be done before anybody maybe from that room could technically start to work. And I wanted to get a grasp of all that work is already been done, or if it still needs to be done.
Like I said, we have data that could serve to you know, to approach, I think, the development of the algorithm, but for sure we will need another design. But we do at the, so I am the co-director of a big lab called the Centre d'études sur le trauma, and we have many partnerships and with several organizations, and we could manage to do this study quite efficiently.
Okay, thank you very much.
Thank you. We have another question from Professor Sabine Bergler. Professor, the floor is yours. Don't forget to unmute yourself.
Indeed. Indeed, I'm working on my cell phone and in a difficult interface. Do you see and hear me now?
I hear you, but I don't see you.
Okay, is it better? We just move on. You don't need to see me.
Yes, I see you. Now I see you. That's okay.
It was good to hear, and like the previous speaker here, it's difficult to get the data into the shape for the various machine learning and natural language processing pipelines. I had one thing. I wonder whether you're aware of the work by Régent Plamondon at UDM, who works on handwriting and fluent, actually, handwriting analysis. And I think from what you just said, you would really like to talk to him, and vice versa, because he has been working on similar type of questions and data, obviously not with your focus, but yeah. That's mainly what I wanted to contribute here. On the other hand, I would also like to see, of course, how to contribute, and whether you've looked, because you spoke of regional dialects of French, right? Which is one thing, and I'll grant you, even so I think that's maybe less of a problem, because with the sort of globalization of media, people will be able to sort of speak a standard French if they talk to a therapist, you know, or to their paper as if it was their therapist. However, what I think is harder to overcome are sort of cultural dialects of, you know, where you have different subgroupings, where they group in certain social media, where I think the language variation may actually be much wider. I mean, the accent, yes, from just the hearing from the north of Quebec to the south seems harsh, but I wonder whether in terms of content and use of actually different wordings, these kind of cultural subgroups, sublanguages, are not more A, difficult to detect, and B, difficult to overcome, and whether there is clinically anything that, because therapists must be dealing with that also, right? Whether there's anything from the clinical side, how that could be addressed.
Sorry, is that a question or?
Yes, it's a question.
Of course it can. Of course it can. But the cultural adaptation of psychotherapy is not an easy challenge to overcome. We talk a lot about that, and that's perfect. There we tend to you know, to try to adapt our approach to Asian people, to, you know, to Indian people, or but the fact is that the best therapist for an Indian person would be an Indian therapist, I think, to understand the culture. So for a single therapist to be knowledgeable about several cultures is a big challenge. And so, but this is, I don't know if I answer your question, but probably that it would, you know, it would be well, a challenge for text mining as well, I guess. And sometimes, of course, some words have stronger meanings than others, depending on culture. And well, I think it would be part of the refining of the algorithm, I think.
Actually, what I may just, do I have a chance to give a quick reply here? Because I was actually thinking more, not of that kind of global culture, but really subcultures, and or not even culture, but for example, I see people who read a lot and who self-diagnose and who read a lot about psychological whatever on the internet will all of a sudden develop a kind of language to talk about symptoms because of what they've read or which other people they hang out with. And there's all these very tiny little sub-languages that are not easily, I mean, if somebody really, comes from India and you know that to demarcate that, it makes it already a little bit easier. But these real sub-languages, I find, they're going to be real distractors in our systems.
Well, I take good note of that, and hopefully in future collaboration, we will be able to manage that. Thank you.
Thank you.
Thank you so much for these questions, and thanks for your presentation again, Professor Guay. Really interesting, and naturally we have the chance of keeping you here for our panel right now. So what we're going to do now is we're going to start a discussion panel on the topics that we've explained today. We're going to welcome our two presenters, Professor Huang and Professor Guay, and welcome three others participants. We have the chance of welcoming Jorge Armony, who's a researcher at the Douglas Research Center and an associate professor at the Department of Psychiatry at the McGill University. We have, again, we're very fortunate to be welcoming Amal Zouaq, who's associate professor at the Department of Computer Engineering and Software Engineering and Polytechnique Montréal, and who's also a member of the consortium. And last but not least, we're welcoming Jian-Yun, who's a full professor at the Department of Computer Science and Operations Research at the University of Montreal, a member of my lab, Rally Lab, and who's the principal investigator of the CLIQ-ai consortium. So our presenters and participants will take part in this panel, and Jian-Yun is going to be the moderator, and at the end of this panel, everyone will have the opportunity to ask their own questions, but feel free to type your questions in the chat, and Jian-Yun is going to relay them during the discussion panel. So without further ado, Jian-Yun, I'm going to hand it over to you.
Yeah, thank you, Fabrizio. And thanks to all the panelists to join this panel. I think this is a really an interesting problem to use NLP techniques to deal with mental health problems. And this is also very challenging. In the panel, we are going to go through a few important questions and to see how we can apply NLP to deal with different mental health problems. So we have two groups of researchers on the panel. One group is on psychology, psychiatry, and the other group is on NLP side. So that's very good composition to have some conversation between two groups of researchers. The questions will try to deal with first the nature of the problems of mental health, and the second one is how NLP can help deal with those problems, and the third one is the remaining challenges that we are facing. So we'll go through those questions. Maybe the first question is to have some kind of understanding of mental health problems, to try to see what we can deal with and what we can't, or that's difficult to deal with using NLP techniques. So maybe the first question is a kind of distinction between the psychological mental health problems and neurological health problems. So do you see some kind of a distinction between those two categories? So those questions may be more oriented to Stéphane and Jorge. You are more in these domains. Maybe Stéphane, you can start, or Jorge. I don't know what's the order you can choose. Yeah, go ahead, Stéphane. Yeah, you're muted. Yes, Stéphane, you are muted.
Really sorry. I was going to let Jorge begin, but that's okay. I can start. The distinction between the two, of course, is probably with regard to the impact that we will be able to have. Many of the psychiatric disorders or mental disorders will be more, of course, determined by psychosocial variables. So many of the depression will emerge from stressful events, as well as anxiety disorders, as well as post-traumatic stress disorders, as I already talked to you about. Of course, there are other disorders that will be more related neurologically to the person who experienced them. Let's talk about schizophrenia, ADHD, or autism, and so we will. But we know that for those who are more caused by neurological factors, those will also induce stressful events that will then grasp also psychosocial determinants. So we do not. It's not like it's a no-go for those who are more neurological, because they live in a social environment that will create or exacerbate sometimes the level of dysfunctioning that is related to their disorder. So so this is one of the distinction, and we also I think we need to think about those who have strong genetic also roots, or stronger genetic roots than others, and I think I can affirm that there are the way that we treat these mental disorders for those who are more neurological. We will probably relate more on medication, of course, to modify certain aspects of the brain, but otherwise, even for those who are more neurological, very often a more psychosocial therapeutic way of targeting difficulties will be used also to get them to a more functional, a more optimal level of functioning in the society. So in that sense, I think that we could use NLP to help them as well.
Good. Jorge, you are muted. No, we don't hear you.
We don't hear you, Jorge. Your microphone doesn't seem to be.
No, we can.
No, still can't hear you.
So maybe we can send a message while the team. Let me try.
Well, I think he can hear, but he can't. He doesn't have a mic.
So you probably need to go to your settings and change the microphone.
I hate Teams. Did I say that?
Yeah, that's okay. So we can hear you now.
Every time I use Teams, that happens. Sorry about that. So yeah, I'll start again by saying that I was saying that Jian-Yun was saying that there are two groups in this panel, and my disclaimer was that I'm neither, because I'm not a computer scientist, but I'm not a clinician, so I'm trying to be somewhere in between. So I'm going to answer these questions in a very vague way, but I think it's sort of this distinction between neurology and psychiatry is similar to some extent in spirit as was psychology and neuroscience back 20, 30 years ago, or cognitive science and neuroscience, and that led to the field now quite established of cognitive neuroscience. And in a way, the similar thing can be said about psychiatry and neurology and neural basis in the terms of neuropsychiatry, right? That is this idea that in order to treat an individual, you have to, target different levels, both from a psychological point of view, from a neural point of view, from a social point of view, etc. So I think more than distinguishing them, I think it's something that you're all familiar with. I think like to think more about level of description, levels of explanation. So you can address some of the issues from a neurological or neural point of view by medication, treatment, etc., and from a more psychological way in terms of therapy, psychotherapy, and so on, and even from a social point of view, from social support, and even from a policy point of view, from policy and so on. So I think we need to do it. Obviously, NLP, I see that it's unlikely that it's going to get into people's brains, at least not for now. So it would be more appropriate for the more psychological aspect of it. But I think one question related, or maybe not to this, but it got me thinking about hearing the talks and this is NLP better suited for, I mean, we've done a little bit of work with Jian-Yun, so I'm using this as an excuse, better for treatment, for prediction, and also and for targeting, let's call them patients or people with already diagnosed or potentially clinical disorders, or the general population that have high anxiety, depressive symptoms, that they're not necessarily qualified as having major depression disorder and so on and so forth. So I wonder if maybe both, but I wonder if it's more realistic, at least in the short to medium term, to decide which group is better suited for this type of approach, and maybe then that would help narrow some of the parameters and we talked about, and I think we'll get back to the challenges in terms of the sample size, the type of information that is being used, and there was a lot of talk about these accents and cultural variation. So I think that that's one of the questions that I have, is what is NLP better for one, for the other, or it's agnostic to that aspect. That's one of the, it's more of a question than a statement.
Yeah, those are interesting questions. So that makes a connection with NLP, I think. So the next big question is how NLP can help there. And so while you were talking, I'm thinking that you basically mentioned two aspects. One is detection, how to detect the mental health problems, and the second one is treatment. And maybe they are related, but they can use different approaches. In the talk of Minlie, he also mentioned how to recognize the mental state of the person, and they try to select some direction of a conversation. So it is the second part is in the treatment part. So orient the conversation in some directions to help the person. So those two problems, are they related, and or how we can deal with those two problems in NLP? So we are going to connect that to NLP. So when you talk about natural language, you may think of natural language as some kind of a behavior, that is, some person may behave in putting some sentences or have some kind of a conversation. And then you can also use NLP as a kind of a treatment to have some comforting conversation with the patient. Okay, so those are the two big categories of NLP tasks in dealing with related to mental health problems, right? Then we may move now to the next question: how NLP can help dealing with those problems. Who is going to start? Amal, do you have? Yeah, so I will give you a chance to talk.
Okay. So first, disclaimer: I'm not at all specialized in psychology, so I will simply have my my information extraction, natural language processing hat here. I believe that on the detection side, there are already a lot of studies that seems quite successful at least extracting some indicators of problems. And the first speaker highlighted several of those. So I think that that's an avenue, and I think that perhaps generative approaches for dialogues and having interventions are more challenging, but that's perhaps just my personal take on this problem. But I think that the main problem is really the data on which we learned those models and where we take this data from. So, for example, there are a lot of, it seems, studies that focus on social network data, for example, Twitter. And we know that Twitter users are predominantly young. So what type of interactions can we make on that? Does it have an impact on the detection and also on whatever we can do with those models is an important, I think, question. So that's more a challenge than a solution, but that's what I could say for now.
Yeah, very good. So we are going back to that data problems, and that's a huge challenge, and we'll be going back to that question. Minlie, do you have something to say about that? Yeah.
Yeah, thanks. So imagine we have a very smart chatbot. So the chatbot can talk to you every day, and then we can build a very tight connection, a tight bond between you and the chatbot. So we have a lot of things to imagine in this situation. For example, when we talk to the chatbot can detect what you talk about and detect your emotion from your text and from your speech and even from your vision. So I think this kind of thing can be used for mental for detecting mental illness. And I think for the intervention, so when the chatbot is very it's very familiar with you, and he can recommend treatment or training program or what kind of advice for you to deal with your emotion and the mental health problems. So I think in this case, with the power of the modern conversational techniques, I think this could be come into reality. So in the future and in nowadays we have many NLP techniques for detection. For example, if we want to do suicide detection, So the user may say very subtle things to you, to the chatbot. But if we have very smart techniques, we can detect that early signals for very dangerous things maybe happen, right? So maybe the user can say, I don't want to I don't want to wake up anymore next day. So this is a signal for dangerous things, and also for the intervention. So we have a lot of space to do in this case. So I'm confidently that in the future we will have a lot of things with NLP technique for mental health problems. So that's what I'm going to say.
Yeah, very good. And from psychological side, what kind of problem that you can see could be detected from natural language? Well, I mean, some of those problems may not manifest necessarily in language, but some problem may be detected from language because we are talking about NLP. So what kind of signals could be possibly captured from natural language? Do you have some ideas of bigger categories of signals that we can focus on? Jorge or Stéphane?
Well, I think that so since I'm a psychologist, and the work that I do with patients often lies in what we call cognitive restructuring, right? We try to modify those thoughts that are, impacting their behaviors as well as their emotions, and we want to modify them of course, in an adequate way, and so that they can after that, instead of being stuck, they can process and maybe resolve problems more adequately, and then go on with their life. I'm just simplifying here, but we try as therapists, we try to have access to their thoughts. Having access to patients' thoughts is a very challenging thing to do, because there are a lot of filters. So people tell you what they think, but through different filters. And so we have to manage with different techniques, Socratic techniques, and to get to the core thoughts or the core cognitions that are causing their distress or their disorder. But this is a hard task to do. So, and we need to, and this is why they need a therapist to get to these core thoughts, because alone by themselves they are just blurred by their filters. So it's not an easy. It's the way people talk or describe what they're experiencing or what they think. If you ask them to do that spontaneously, you will not necessarily get, the exact thing that you want, that you're looking for. So it's I think it's a tough. It's some sort of an exploration that we have to do, and at some point we might get some indicators of core thoughts that are approximate of those who are, causing the distress or maintaining the disorder. So this is a hard way. It's not an easy task to do, but we have to try. As Minlie is saying about chatbots, maybe we can get people to say things by prompting some questions, to them, and have them say exactly. And with the work of AI, I think that we will be able at some point to get there, but it's a hard task. You asked also what kind of problems we could think that we could use NLP to help. I think suicidal risk is probably one of the more, even though maybe scary to work with, it's probably one of the problem that we might be able to detect across different things, text, posts, and Amal talked about social media. I mean, people are everywhere so I think there's something there that we could work through. And of course with PTSD, as I told you earlier, so maybe with the writing, but with maybe some sort of a structured writing, or we can, or coached writing, we can get to approximately closer to what we're looking for as the specific ingredients of language that are related to the factors that causes or maintain the disorders. And one last thing I would like to say is that for those who are more neurological, I told you that other psychosocial factors could increase, exacerbate, or help, like good social support can do. But I think one target that we could easily get to is the representation that these people do of their mental disorders. So how do they think about the ADHD? How do they think about their schizophrenia? And the way that they think, that they represent this illness, it can be changed in a positive way, so that they can function better in life.
Thank you. I'll move to Jorge because we were both involved in working with suicide detection. So you can talk about that problem.
Yeah, sure. Yeah, so I'm not sure I have too much to add what Stéphane was saying. I think again, we're going back and forth between possibilities and challenges, and one of the possibility, the good thing in a way is that yes, even before the existence of computers and stuff, people were talking about narratives, and particularly in PTSD, to build a narrative. So although the narrative is a more complex concept, we are language beings. So a lot of the things we do is through language, and written language. It's clearly captures not everything, but captures a fair amount of the information we want to convey. We're living out, and I was leaving that for the challenges, but I'll put it here, is half these days of my work is on prosody, and prosody in written language doesn't exist. So that's a huge thing that I think it needs to be addressed in the future. On the plus side, I think that talked about the use of Twitter, and we use that, and it's the young generation, and I think that's a good thing in the sense that so one of the things that I maybe I'm wrong, but what I see in most of the on the AI systems that try to detect emotions or psychiatric disorders or whatever, they base on short sentences or little paragraphs, where more I think sort of taking what Stéphane also was saying in terms of a therapy, it's a long convoluted almost stream of consciousness type of things, where you move around, and so I want that could be a challenge. But on the other hand, again, this is from somebody who hates Twitter and things like that, but the new generations are very good at condensing information. They're really good at, what we would take 20 minutes to say something, they say it in whatever 130 characters. And with the emojis these days, they don't even have to write anything. They just put things which we think is random, but they know exactly what the other person is feeling. by just looking at not just the the individual, the order, how they put them. So I think we and that's AI perfect. So I think that would be potentially another source of information that is not even language anymore. It's meta language, if you like, but it's extremely specific, but also very expressive. So I think that's one avenue where almost prosody can, it's a sort of form of prosody can come in, because they typically say, we've been through this, Jian-Yun and in the suicide. If you say, I want to kill myself, and it's because either I want to kill myself or because my team lost, in yesterday's match. And the text is exactly the same, but I was thinking about this right now. Is if depending on the emoji you may add at the end, that will change completely. If you put a little funny, face, whatever, you say, oh yeah, I know it was terrible that they lost. They played really bad. But if you put somebody, literally crying or something did, then you might interpret that is really something that they're feeling, or if they don't put any. So I think that we might start building this into the system could be, something potentially interesting to look at.
Yeah, very good to mention that. And we're going to pursue on the same question, but Jorge, you mentioned that you have some commitment at 11, so just feel free to leave when you.
I can stay a few more minutes.
Oh, okay,
Yeah.
Great. So the next question is how we can detect these kind of signals from information extraction or whatever deep learning perspective. So those are questions more to Amal and Minlie. Do you see some? I'm sure that you see a lot of challenges. Do you see some opportunities to go in that direction to try to detect those signals? And Jorge just mentioned some complexity about the same expression used in different contexts. They may mean different things. So those are huge challenges to NLP, right? So maybe Minnie, if you can, you can start. Yeah.
Yes. So I think there's two challenges for this. The first one is detects all the signal from the social media is very noisy. So it's very hard to get the high quality data, and also how to cleanse the data is also very, very challenging. The second one is if we just talk about text, so the signal is very weak. I mean, it's not a strong signal for detecting, for example, mental illness problem. And let me give you an example. So, for example, if we use the detect the emotion, so emotion classification or emotion recognition is a non-standing problem in both NLP research and also in multimedia research. So for text is very weak, and many information is missing. So we need other modality data to get more accurate predictions for this. So I think in the future, if we have really good dialogue system technologies, so this could be elevated to some degree, because if we have this kind of conversational partner, so we can have we have a possibility to access all kinds of information. And yeah, this is the two challenges that I can see for the moment.
Thank you. Amal, anything to add?
Perhaps if we think about what is the models that work really well currently, which are in general deep learning models, Well, they require a lot of data, right? And generally annotated data. Of course, there are many other techniques that started emerging, such as few-shot learning, that might help us there. But I think that how we would obtain this type of data and whether we would be able to generate some types of artificial data also, or have automatic ways or semi-automatic ways to annotate data with different elements of interest would be crucial for this type of neural models to work. So that's one aspect. And the other aspect comes back to what I was referring to in my first question in this panel, which is an analysis of really the failures of deep learning models, especially when there are so many dimensions that are involved. So, for example, if we talk about depression in a particular situation, I assume that we must have knowledge also of that particular situation, and it involves common sense knowledge, this involves domain knowledge, this involves many other knowledge, plus an ability to have a long memory. So having an understanding and an ability by the models to recall information on a large more or less large sequence or time period. So I think these two aspects would be crucial to understand also how those models could be used, because it can be very difficult or very problematic if we have wrong interventions or wrong conversations with a patient or someone who is experiencing difficulty. I often start my NLP class with a fun or between bracket example where I have someone saying, I feel terrible, I would like to jump from a bridge. And you have a natural language interface that answers, well, there are 7 bridges not far away, and tells you where they are. And obviously, we don't want this type of reaction by an AI. So I think that's why I was saying that it's very important to work on the generative systems, but I think there are many aspects that are still not well controlled to be put in real situations. So that's I would like to add for now.
Yeah, very good. I think that leads to our last question about the data that we should rely on to train our model, because most of the approaches are data driven. And another related question is about knowledge. So in this area, when people talk with psychologists or someone in the profession, it is not just data driven. So it is driven by a lot of knowledge acquired during the training or acquired through experience. So this kind of knowledge will be crucial, I think, in trying to deal with mental health problems. So those are two aspects in our last question. How, is it possible to just develop data-driven approaches, or should we incorporate some domain knowledge used by professionals? And how can that be done? So this is a big question. And Minlie mentioned some involvement of human knowledge in your systems. So can you just talk about how the knowledge is involved, is used?
Okay. So yeah, this is a big question. So particularly in today's large scale language model is very popular. Oh, sorry. So today, large-scale language model is very popular, and we can see OpenAI, Google, and Facebook, and all kinds of big IT companies developed different kinds of language model. So this is a purely data-driven, and because just put all kinds of data into one model, really big model, and then just deliver the language generation understanding. So I think in mental health applications, data is obviously not sufficient for all this applications. For example, in our chatbot, we try to understand what kind of counseling strategy used by the human professionals. So we ask the professional annotators to label different strategies at different contexts. So I think this is kind of very strong domain expertise used in the knowledge. And then we use the strategy code to control the generation of the model. So I extremely agree with Professor Amal, right? Zouaq here. How to spell? Sorry.
Zouaq.
Yeah. Yeah. So I totally agree with you because the current generative model is not so controllable. So in this case, it's very dangerous if you deliver an improper response to the human being, considering the human being is still in a trouble, right? So this is very dangerous. So we should be very careful. However, they're also undergoing works focusing on, for example, improving the safety of the generative model, and also how to make the model more ethic and more following the social norms. So AI is developing very fast. So I mean, so I think there's a way. There must be some way to embed domain knowledge into this kind of applications, but it's very expensive and very time consuming. So that's my point. Yeah, I totally agree. Knowledge is very, very important.
Good. Jorge and Stéphane, something to react up about what the type of knowledge, domain knowledge that you can see possible to inject into this kind of a system. That could be dialogue system or even problem detection system. Stéphane, you can start. You mentioned some the problem of detection. So detect those problems. We mentioned the type of features, but do you see other type of domain knowledge that you can use to guide the analysis?
Well, where we are at now, we're trying to explore and identify other factors that we could measure, of course, either steadily, that could be geographical, moving, yeah, or cardiac reactivity, in addition to, because sometimes it's the interaction of factors that will guide us in the identification of risk factors, for instance, and not just one thing. But with something that is more closer to NLP, I think is the expression of emotion, the facial expression of emotion, and it's not an easy a project to do, because of course there are ethical issues related to that. Should teams analyze my facial expressions during this talk, and at the end say if I was either anxious or depressed during. So being analyzed continuously is of course some sort of a difficult thing to investigate or to to work with. But if I think like a clinician and that would like to improve my interventions, my psychotherapy with my patients. In PTSD, we do certain strategies to, as I told you, we ask the people to do the narrative of their traumatic event. So, but when we do so, we want people also to experience anxiety during this narrative. This is how we gain the therapeutic, therapeutically. And if the person is not connected to their emotion and they just tell the story of the event, then we should be we should be concerned about that, because that means that we are not targeting. There's a filter. Either we're not targeting the good memory, or that there is a filter that make it difficult for the person to experience the emotions that she would be normally be experiencing when she's talking about her rape, for instance, And but this is not always we're not always able to detect that with our eyes. So we would need something more finely grained analysis, and maybe by wearing some type of glasses, that could tell me, well, your patient is not experiencing anxiety at the moment, so she might be dissociating from the traumatic memory. So, and then this could lead me to do another type of intervention that would be more helpful. So I think that could be a helpful addition, and it could be, of course, it needs to be driven live, because I need this information right away in streaming. So it cannot be done afterward. It needs to be live right now. So that would be my answer from my clinical perspective.
Yeah. Very good. So I assume that it will need a lot of professional training to recognize these things, right? Yes, we're moving to the last question about data sets. So there is one question in the chat talking about the possibility to get data from social media. And on that, Jorge had some experience because we worked on that. Is it possible to get enough data to recognize different mental health problems, or how is there any possibility to increase or to augment the data? So you mentioned that idea when we were discussing. Yeah, go ahead.
Yeah, so this is a question that we with Jian-Yun and have been talking for a while. So yeah, in terms of data, the two main challenges that I see, and I sort of briefly experiencing with this collaboration, is obviously that at the end of the day, this is data driven, but it's supervised learning. So that means that somebody there's a ground truth, and the system can only learn based on the ground truth. So first, if the ground truth is not really ground or truth, then we have a problem. And so we need somebody to give us that categorization. And so it's easy to say, yeah, I can have 3 billion tweets. Okay, then I need at least 100,000 undergrads to go through those and then cross-validate and think, and because again the prediction will be only as good as the real data or the real classification. So that's something that we already sort of encountered. And when it's easy to say, to categorize things in a very broad sense of happy, sad, blah 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 blah. But if the goal is to move to more subtle predicting or understanding psychiatric disorders, suicide, and so on and so forth, then it's much more subtle. And there's actually not a lot of agreement, maybe even at the level of humans, on what a certain stimulus, which emotion conveys. So that's one big challenge. And the second, which is sort of related to that, is sample size. And again, we talked about this many times. Is obviously in order to train, you need very large samples, and that's why deep learning can be done now and it couldn't be done 20 years ago. And so on the one hand, the good thing is that there's a lot of people on Twitter randomly saying a lot of things. So there's a lot of data. But as we experience, again, with Jian-Yun, I'm sure all of you that work on this have, the good news is that there's not a lot of people who are talking about committing suicide. So from a psychological, psychiatric, social perspective, that's great news. From an AI deep learning perspective, that's really bad news, because out of thousands and thousands and thousands of tweets, we end up having a dozen that are probably indicating some serious risk. So we cannot train a system on that. So we talked about, again, this is well beyond my expertise, but we talked about the possibility of generating data, which kind of, in fact, solves or bypasses those two problems, because on the one hand, you can generate an almost infinite amount of data, artificial synthetic data, and also because the way you're generating, it's already categorized. So you don't need to recategorize. I mean, you need to validate it, obviously, but once the system is validated, you can generate variations on a theme that they're actually meaning the same thing. So kind of that, I see that as a potential avenue to increase data without sacrificing quality and having the ground truth built in as a generative system.
Thank you. Well, among the panelists, do you have anything to say about that, or about any questions? And then I will open the discussion to all the audience. No, that's fine. And in the audience, do you have anything to talk about? Any questions or any additional points you want to discuss?
Maybe one point, if I may add, like in
Sure.
this case that we have data scarcity, in case, is it, I don't know, I'm asking your point of view. Is it correct approach to go for anomaly detection? For example, when we have thousands of tweets, and then we find a pattern of those that are not like according to the normal tweets, or let's say people that have healthy mental states, and then categorize the rest as the like people that they need some help actually.
Anyone wants to react to that? If not, I can give my first answer. I think the question is about the normality. And the normality is in natural language processing and in particular related to mental health. It is very difficult to define and to build a model for. This is because of a great variation in natural language expressions. So you can talk about the different topics, and you will not be able to collect a lot of discussions on the same topic, and they try to determine what's the normal way to talk about that topic. And just imagine now that you can talk about any topics during the conversation, and that makes the definition of normality very difficult to do. If we could do that, that would be well, the detection of anomaly would be easy, but I think the normality is very difficult to define in that case. So that's my take. Yeah, Fabrizio.
Yes. Well, I have a question. Up to now, the therapeutic sessions are made between two humans naturally, and they chit chat and they come up with solutions or therapeutic avenues. But if we use that as a training data for, say, a chatbot, it's not entirely representative because a human who has mental health problems interacting with a robot or a chatbot, a machine, may behave much differently than with a human. Professor Gay mentioned that some people have filters and barriers on some of the things that they express during a session, but these barriers may only manifest themselves when speaking to a human. They may be more forward or honest when speaking to a machine. So I'd be curious to hear your opinion about that.
Yeah, maybe I can answer the question because we have a Emoha chatbot, and then we deliver the service via the WeChat account. So we have more than I think more than 3,000 users chatting with the chatbot, and we can see some users are really how to say are really lonely, and they need someone to talk to, but there's no human being they could seek help from, so they go to chatbot for this kind of service. And also we found that in some particular human population, I mean, for example, for the young kids and the children, they are very curious about using the chatbot for maybe for fun, not for mental health service. So there's different people. They have a preference for the chatbot, and so we can see some opportunity in this kind of people, and they need help. They really need help, and they trust the chatbot, and they want to talk to the chatbot. So in the log, in our system, in the log, we looked, we check the log every day because you want to see what kind of people are using our service, and what they are talking about, what are the topic, and what are the trouble they are facing with. So we see some people has a very long conversation, more than hundreds of turns. So they have a very long connection with the chatbot. So this is what we see in our system. So I believe in the future, if the AI technique become more and more mature, and their intelligence level become more and more with more and more capabilities, so we can see maybe in the future we can change many things. So I don't know whether you know the character AI in America. This is a very famous startup. No, a very hot startup in recent few weeks. So they can deliver very chatbot specific to different style, to different character and different roles. They have a kind of a life coach, and they have counselors, and they have learning partners. So AI can build a very tight connection and a very tight bond with the human beings. So in this way, we have new opportunity to deal with the mental health problems. So this is my point. Yeah.
Yeah, great. I like the mention of human sailors in the loop. That's a typical human in the loop approach. I think in the course of utilization of your system, it is possible to accumulate data and accumulate data loosely annotated by human experts during the utilization, and that may be one approach to solve the data sparseness problem. I think it's about the time to conclude. Anything to add about that? Yes, one mentioned about the unsupervised clustering techniques. Yes, it is indeed possible. Yeah, I agree. So in the chatbot, not chatbot, in the chat, there is a mention about utilization of unsupervised clustering techniques. deal with that. It could be possible to alleviate a little bit the data problem. Indeed.
Yeah, it's indeed a critical problem for this, and I'm really glad that we discuss this topic. I think it's at the center of this discussion, but more broadly at the center of this consortium, because it's an important research question. So with that, I'm going to thank all the researchers who joined us today. We were very, very fortunate to welcome you all. It was a real pleasure to understand your point of view on that question. If you have ideas of collaboration with Professor Guay or Professor Huang, please reach out to them. I'd also like to thank my collaborators for organizing this meetup. And as always, a recording of the event will appear on our website, CLIQ-ai.quebec. So that's it for today. I'm going to thank everyone. I hope you enjoyed the presentations, and stay tuned for more news about the upcoming meetup next month. Until then, have a pleasant day.
Thank you very much.
Bye. Bye-bye.
Really enjoy that.
Yeah. Nice to meet you. Bye-bye.
Yeah.
Thank you.
Bye-bye.
Bye.
Thank you again.